Welcome to the Bare Metal Cybersecurity Plus podcast. This series helps you prepare for the CompTIA Security Plus exam with focused explanations and practical context. For a companion study guide, check out the Achieve CompTIA Security Plus 701 Exam Success by Dr. Jason Edwards. It is the most concise and complete Security Plus guide on the market, built for busy professionals who want to pass the exam fast and on their first try. You can find this book and others at cyberauthor.me. In this episode, we are looking at advanced cryptographic techniques, specifically key stretching, blockchain technology, and practical challenges in implementing these solutions securely. These methods represent some of the most powerful tools in modern cryptography. But, like any tool, they must be understood and deployed correctly to achieve their full security potential. Let's begin with key stretching. Key stretching is a technique used to make weak or short passwords more resistant to brute force attacks. It does this by processing the password through a cryptographic function many times in a row, greatly increasing the time and effort required for an attacker to test each password guess. One of the most widely used key stretching algorithms is password-based key derivation function 2. This method uses a salt and applies a cryptographic hash function thousands or even millions of times to produce a derived key. Another common method is bcrypt, which automatically incorporates a salt and is intentionally slow to compute, making it highly resistant to fast password cracking tools. These techniques are especially useful in systems where users often create passwords that are shorter or less complex than they should be. By stretching the key, the system adds a layer of protection without requiring the user to do anything differently. Real-world scenarios highlight the benefits of key stretching. In one case, a popular web service was breached, and attackers gained access to hash passwords. Because those hashes were protected using password-based key derivation function 2 with a high number of iterations, the attackers were unable to crack the majority of the credentials, even with powerful hardware. In contrast, other companies that stored unsalted or lightly hashed passwords saw widespread account compromise when breaches occurred. Now let's move to blockchain and open public ledgers. Blockchain is a distributed, cryptographically secured database that records transactions in an immutable chain of blocks. Each block contains a list of transactions, a timestamp, and a hash of the previous block. This linking of blocks creates a structure that is extremely resistant to tampering. In cybersecurity, blockchain is best known for its role in cryptocurrencies like Bitcoin and Ethereum, but its value goes far beyond digital currency. The key strength of blockchain is that it creates a shared record that no single party controls, yet all participants can trust. Once a block is added to the chain, it cannot be altered without changing every block that comes after it, a task that is computationally unfeasible in large networks. Cryptographic principles are at the heart of blockchain's integrity. Digital signatures are used to verify transactions, while hashing ensures the accuracy of each block. The decentralized nature of blockchain means that tampering with one copy is not enough. Any change would be rejected unless it matched the consensus of the entire network. Case studies demonstrate blockchain's potential for secure transaction recording. In the shipping industry, companies use blockchain to track cargo containers, ensuring that records cannot be falsified or lost. In the food industry, blockchain helps track the journey of produce from farm to store, increasing transparency and trust. In healthcare, some organizations are exploring blockchain to create tamper-proof records of patient consent and treatment. Blockchain also has applications in identity verification, smart contracts, and secure voting systems. Each of these use cases benefits from the core strengths of blockchain: transparency, auditability, and cryptographic security. Finally, let's discuss practical implementation considerations. Advanced cryptographic techniques offer strong protection, but they come with challenges. One of the biggest is performance. Key stretching functions like password-based key derivation, function 2, and bcrypt are intentionally slow. If the server has to process a large number of logins quickly, the delay can create bottlenecks or degrade user experience. In blockchain systems, performance and scalability are also concerns. Public blockchains can only process a limited number of transactions per second, which can make them impractical for high-speed applications. In addition, the permanent nature of blockchain records creates legal and compliance questions. What happens when data must be erased to comply with privacy laws like the General Data Protection Regulation? Another major consideration is complexity. Implementing advanced cryptographic systems requires specialized knowledge. Poor configuration can undermine the entire security model. For example, if a key-stretching algorithm is used with too few iterations, the benefit is lost. If a blockchain application does not properly secure private keys, attackers can take over identities and transactions. Finally, cost and infrastructure requirements must be considered. Dedicated hardware, secure key storage, and redundant systems are often needed to support enterprise-grade cryptographic solutions. Organizations must weigh the benefits of these advanced tools against the resources required to maintain them effectively. As you prepare for the Security Plus exam, be ready to explain the role of key stretching, understand how blockchain achieves security through hashing and digital signatures, and identify the challenges that come with deploying these technologies. You may encounter exam questions that describe a scenario involving password protection or data integrity and ask you to select the appropriate cryptographic method. Pay attention to keywords like derivation, immutable, and distributed ledger. These often point to advanced cryptographic concepts. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.